Hey everyone, my name is Hamza Asad, and together with William Luna and Ian Herdigen, we are going to be discussing the BuyMySpot Analytics. So before we delve into the more sophisticated aspects of this project, we first wanted to briefly give an overview of the company that we are working with. BuyMySpot is a student-led initiative slash startup that aims to ameliorate the persistent parking problem that plagues Ann Arbor and college towns in general, really. So in parking towns, parking is very much viewed as a valuable commodity, and it can be frustrating to sometimes drive past dozens of empty lots and driveways. So therefore, the creators of BuyMySpot thought of ways to connect homeowners, landlords, community centers, places of worships, and businesses to list their parking spots for rent while simultaneously giving students, residents, and visitors a more affordable option for parking. So for those who own parking spots, they can easily list as many parking spots as they want for free on their easy to use, user-friendly, um, interactive module. And that can easily serve as a source of passive income for them, for the people who are leasing their parking spots out. And for students or residents looking for parking, they can easily book the parking spots for at a daily, weekly, or even monthly prices. So in terms of our motivation, the purpose of this project, we wanted to undertake an investigation, drawing information from two different sources of data and seeing if we could construct a story using that data. So the purpose of this project was to kind of act as data scientists for BuyMySpot and see if we could identify opportunities to advance or leverage the business function and find ways to maximize profits. The specific questions that we were trying to uncover is whether there was a correlation between parking tickets received and parking tickets received specifically by students, and parking spots available within those particular geographic zones or areas. So we divided a map of Ann Arbor into four distinct grids and based on longitude and latitude values, and we assigned each grid a value from 1 to 4. So in terms of some of the specific questions that we were trying to ascertain, those include like which grid receives the most parking tickets, which grid has the most available parking spaces, which grid has the cheapest parking available, and which has the most expensive. And more importantly, is there adequate parking to address the ticket situation in the region with the most parking?
So moving forward to our data sources, our first data source was the BuyMySpot database, which is on MongoDB, which is a way of storing data on a database called NoSQL. And the way this was accessed was via the Mongo client, which is a Python module that lets you access a MongoDB records using a username and password. And the format returned was a collection, which we converted into a pandas data frame. And the important variables for this were the monthly price of the parking spots and the position, which included latitude and longitude. And there were 43 records retrieved, which are the 43 spots that were sold in Ann Arbor during the time period of April 14th, 2020 to April 14th, 2021.
Our second source is a file for City of A2 tickets, accessible via GitHub. It is stored in a CSV format, and we convert that to a pandas data frame. Important variables that we had retrieved was location and find to kind of find that exact latitude and longitude. Again, to plot on the map of Ann Arbor into quadrants 1, 2, 3, or 4. We were able to retrieve 147,000 records in a time period of January 1st, 2019 to December 31st, 2019.
So the way we processed our data, initially with the MongoDB, we needed to connect to this NoSQL database using the Mongo client in Python. And then from there, we used a for loop to iterate through all of the latitudes and longitudes and determine what quarter of Ann Arbor each spot was at.
We accessed ticket data from the year 2019 based on data from A2 tickets data file. Currently, 2020 was not available given the short timeline for the project, and there had to be a form filed for that. Additionally, we use GeoPy to get the longitude and latitude for each of the locations specified after we had extracted the data to a data frame.
So to our left here is an example of a NoSQL record on the MongoDB on BuyMySpot in the spots collection. This includes data such as latitude, longitude, prices, the address, description of the parking spot, etc. And to our right, we have the code which was used to retrieve these records and convert them out into a CSV that would be useful for our project. So at the top of the code, we are importing all of our modules, PyMongo, Pandas, NumPy, and the Mongo client. We connect the client on the next line of code, which is the MongoDB, and then there's a username and password, which is blurred out. That is the username and password of the NoSQL database. And then we have a data frame created, which is just searching all records in the spots collection. And then we rename the data frame's ID column to be spot ID. And we create some lists, lats, longs, monthly prices, and quarters. And then we set a lat and long for the diag, which we found online. This is the latitude and longitude of the diag at the University of Michigan campus. Next up is our for loop, where we go through all of the spots in the spots data frame and append the latitude and longitude, the quarter, and the monthly price to the respective lists that we created. And then after that for loop, we create the columns in the data frame that match the list that we created in the for loop. And then we filter out full range only spots. Full range only spots have a different price schema on BuyMySpot. They're parking spots that can only be sold for a entire date range as opposed to a monthly price. So we wanted these filtered out of our data. And finally, we outputted this data frame to a CSV called buy_spot.csv.
One of the main aspects was getting the coordinates from the A2 tickets data frame. We started by accessing the 2019 file specifically and adding that to a data frame. Then we set data frame location equal to the same exact thing as it is, but add Michigan to it. This sets us up to use the API to get proper requests for the addresses. And then next we create a unique list because there was 147,000 rows of data. And in a city of Ann Arbor, there's going to be repetition. And at that large of a number, that's a lot of requests on an open source API. So once I was able to get the data formatted in a way that I could use an API to search for the lat and longs, I used a unique list, which condensed it to by about 100% or 10 times less. And essentially, we found that there are common errors within the data. So you can kind of see here on the code on the right, where there's replace statements for missing characters such as South and Washington. Essentially, what we wanted to do was to get as much data as possible. And then we did this in a try and accept clause. So that way we wouldn't have a crash in our request. And then there's a statement for percent if divisible by 50 equals a remainder of 0, print that you received the element. With working with large quantity of data, you do want to see some progress. This was kind of to give us a picture of how much data was retrieved. Next, the next problem was we had to write this to a CSV, partly because we couldn't run this code in Jupyter Hub. It would crash after around 300 requests. And given that we had to go through about 4,500 requests, it was easier to run this in Visual Studio Code and store the retrieved items into lists, as well as including the location. So that way we could later merge the data. But once we were able to get all the lat and longs, we wrote that to a CSV, and then we're able to store that as lock_lat_long.csv. All right, so next we want to go over the code in Jupyter Hub now that we have extracted the appropriate data. And this is so that way anyone who wanted to access these files, they could run this themselves. As some of the data was user sensitive, and we had to like protect that that security, those passwords. So first we load in all the data frames in the first cell to kind of get a picture of what they look like. As already covered the load ticket data, this just gets the year 2019. And then as we had extracted the data previously and created those into a CSV file, we just made a simple CSV to data frame function and called that for the BuySpot data as well as the location data. Next, we work with the data df2, which this is the data from the location. And first we want to go through the data, and because we had that try and accept clause, we did have some addresses saved as no address available for the lat and long. So what we want to do is filter that out so that way we can change the data into float variable type, so that way we can examine it. Once it's in float, we move to the next step, which is identifying the quarters that it belongs in based off of the diag. And this is just simple comparison of greater than and less than. Once we append all of these to a specific quarter, we make a separate column called quarters and set it equal to a list. So that way it is in order with the correct location. Next, we want to merge the data frame. So we merge it on the data frame from the A2 tickets specifically, as well as the data from the location. And we want to merge on location. So we kept location the same, so that way we could merge on something. And what this does is so that way we ran the API only 4,500 times, but on our data frame, the big one of all A2 tickets, we now have that for 147,000 rows of data. Some a little less than 147,000, given that some were stored as no address available. And what that did was allow us to see the quarters as well as the longitude and latitude. So once we had the proper data, both data frames have they have a column named find. They have columns for quarters, and this is to apply a group by function, which is in our next block here. So we group by quarters specifically on find, and then we apply an aggregate function. We find the maximum, minimum, the mean, and the count. And the purpose of the count is to get a composition ratio, which is going to be for comparison later using a chi-square test. So once we have these same exact values, max, min, mean, count, the only thing that is the same is the index, which is quarters. Now this allows us to compare the two data frames, the new merge data frame of tickets, as well as the data frame from the spots, the BuyMySpot data frame. So the two of these merge on quarter specifically, giving you a max X, a min X, a mean X, a count X, a max Y, min Y, mean Y, count Y. So once we have that, we want to look for specific data. So to kind of clean things up, we do change count X to being spot count. Similarly, ticket count for count Y. And this just kind of helps visualize the data differently, make it more readable for the user. And then next from there, we actually visualize the data. We then visualize the data. based off our composition. So for the blue line, that is the spot composition. And you'll see that in Q for quadrant 1. There was less composition of spots, but there was a greater composition of tickets. And these seem to be working inversely almost.
Some other things that we noted and interesting relationships that we saw, we had a few null hypotheses. These were the count of parking spots in each quarter, them all being the same, and then the count of parking tickets in each quarter all being the same. And when we imported a module called the chi-square, this allowed us to do a chi-square test on the observed values shown in the previous slide with the expected values, which is automatically calculated as them being equal. And we see here that we had a chi-square stat value of 10 for the parking spots and 4,143 for the parking tickets. And the p-values for these were 0.0167 and 0.0000 respectively. So with a critical value of 0.05, we're able to reject both of these hypotheses and show that the count of parking spots in each quarter and the parking tickets in each quarter are not equal. There is a difference, which was an interesting conclusion in addition to the previous visualization that we saw where on the past slide where the parking tickets are inversely correlated with parking spots available. Some things that didn't work, we initially wanted to pull in data from the BuyMySpot Stripe account, but were unsuccessful as this required us to build a webhook endpoint, which we were struggling with. This changed the initial direction of our project to focus away from expense data and more towards location data that was available from the BuyMySpot MongoDB. Moving forward in the future, we think it would be really cool to work with the Stripe data for BuyMySpot, as this will allow us to do a lot of cool things for the company, like predicting revenues and expenses and Stripe fees, and have some sort of forecaster to generate month-by-month predictions and for times of the year. So that's all.